Hello friends, welcome back to the channel. So we stopped the previous video here. So let's start from this point, that is parasitic folds. Hinge zones and limbs of large folds often display folds of smaller wavelengths and amplitude. Larger and smaller folds are together polyharmonic. The small folds are named parasitic or subsidiary folds with respect to larger ones. The largest folds are termed first order folds, the next largest are called second order folds, and so forth. The axes of parasitic folds are habitually closely parallel to the axis of the major fold with which they are associated. They are said to be congruous, by contrast with incongruous parasitic folds whose axes deviate appreciably from the attitude of the major fold axis. First order folds may be symmetrical, whereas the congruous second order folds are asymmetrical. The sense of asymmetry, referred to as local apparent divergence, is consistently towards the hinges of higher order antiforms. It changes systematically across the axial surfaces of the first order fold, so that looking down the axial direction, all parasitic folds in a limb have a clockwise apparent divergence and are described as Z folds, whereas those in the other limb have anticlockwise apparent divergence and are S folds. Symmetrical M folds generally occur in the hinge zone. W may be used for synforms as opposed to antiforms. The axial plane of the first order fold links and runs across second order M folds and separates limbs with S and Z second order folds. In the field, the asymmetry is used to locate hinges of the next larger order folds if they were both generated together. Note that flexural slip and or flow provides a coherent explanation of why Z and S second order folds form on the limbs of a first order fold. Parasitic folds would initiate as symmetric buccal folds sheared hingewards during the flexural flow of incompetent layers. Enveloping and median surfaces. The average orientation of a folded surface affected by a fold train is measured from the enveloping surface, which is constructed either as tangential to most or all of the hinge zones in the folded surface. The enveloping surface defines the limits of folds, thus relate the geometry of small to large scale folds in areas where there are so many small scale folds that they obscure the general orientation of bedding. Example, in a tightly folded limb which folds, the enveloping which surfaces touches depends on the scale at which the structure is being considered. So this is enveloping surface. You can see enveloping surface. Yes. Now median surface. So what is saying that enveloping surface and median surface, the average orientation of a folded surface affected by a fold train is measured from the enveloping surface, which is constructed either as tangential to most or all of the hinge zones in the folded surface. The enveloping surface defines the limits of folds, thus relates the geometry of small to the large scale folds in areas where there are so many small scale folds that they obscure the general orientation of bedding. Example, in a tightly folded limb which folds, the enveloping surface touches depends on the scale at which the structure is being considered. Okay, the median surface joins the successive inflection lines. What is inflection lines? We already read in the previous part, okay, of this same PDF video. Now, inflection lines of a folded layer and separates antiforms from synforms. The median and enveloping surfaces are generally almost parallel and therefore yield the same information. Axial planes of symmetrical folds are perpendicular to the enveloping and median surfaces. Wavelength, arc length, amplitude and aspect ratio. Amplitude and wavelength define the size of a single fold and refer to the mathematical terminology used to describe a sinusoidal curve. Okay. Wavelength, so the distance parallel to the median surface between two successive anticlinal or synclinal hinges seen in profile is the wavelength. The median surface length between the inflection points on equivalent left limbs of two neighboring folds is also the wavelength. So see the image, okay, then read. The arc length is the distance along the folded plane between 2 points separated by one wavelength. So arc length of symmetrical, periodical and upright folds. Arc length is the distance along the folded plane between 2 points separated by one wavelength. Now amplitude. The amplitude is measured by taking half the distance along the axial plane from one anticlinal hinge to the surface enveloping the two adjoining synclinal hinges, or vice versa, namely the distance along the axial plane from the median surface to the hinge. A train of folds may fold a surface periodically or non-periodically. The term pericline is applied to large-scale antiforms or synforms whose amplitude decreases regularly to zero in both directions so that the fold has precise limits in space. Domes and basins are periclinal structures. Aspect ratio. The aspect ratio of a fold is the ratio of the amplitude to half the wavelength. Where folding is disharmonic, both wavelength and amplitude of folds vary between successive layers. Now, conjugate folds. The term conjugate describes any pair of identical folds with axial surfaces inclined at a high angle to one another in profile, resulting in opposite versions or in map view. Such folds generally terminate in a fold of yet another orientation where their axial surfaces meet. Conjugate folds with round hinge zones are box folds. Conjugate kink bands, conjugate folds with angular hinges are common. तो ये सारे देखो उतना तो इम्पोर्टेंट है नहीं, बट एक बार पढ़ लेते हैं. Clubs folds in regions folded in near surface conditions, folds with rather shallow dripping axial planes and a local margins opposite to that of parasitic folds are due to gravity driven collapse into the synclinal regions of layers first deepened by folding. Flaps are overturned sequences that result from bent over backward gravitational instability without breaking. क्योंकि यहाँ से क्वेश्चंस कुछ खास तो मिला नहीं, मतलब इस सारे टर्मिनोलॉजी टॉपिक से क्वेश्चंस तो मेरे को दिखा नहीं. वही जो हमारा फोल्ड्स की जो टाइप्स होता है वहाँ से बहुत क्वेश्चंस आता है, बहुत बार पूछा जाता है, तो वो सारे आपका कॉन्सेप्ट जो है क्लियर रहना चाहिए. ठीक है, बाकी हम देख लेते हैं और क्या क्या कुछ है कि नहीं है. Now देखो morphological classification, thickness variation of a folded layer. Structural geologists have long used the shapes of folds for determining the amount of shortening due to folding in layered rocks. They have elaborated a range of techniques to estimate shortening from fold shapes. तो हम ये जो भी है मैथमेटिकल पार्ट है तो इसको हम नहीं पढ़ेंगे, इसको नहीं चाहिए हमको. ठीक है, बाकी मैथमेटिकल पार्ट है. तो फ्लैट एंड फोल्ड्स, ओके, ये भी वही है. बहुत कॉम्प्लिकेटेड सी चीज़ यहाँ पर दिखाया गया भाई. ये अच्छा है बट थोड़ा टफ है, समझना थोड़ा टफ है, मतलब हार्ड है थोड़ा टर्मिनोलॉजी जो भी है. ठीक है, नाउ फॉल्ट रिलेटेड फोल्ड्स, इसको एक बार पढ़ लेते हैं कि मैनी फोल्ड्स आर एसोसिएटेड विथ एंड इन जनरल कंट्रोल्ड बाय द जियोमेट्री ऑफ फॉल्ट्स. ड्रैग फोल्ड्स, सो बेडिंग इज फ्रीक्वेंटली बेंट in fault zones. These local flexures are known as drag folds and fault drags. They usually are convex towards the direction of the fault movement and are thus attributed to some frictional resistance to slip along the fault plane. This interpretation suggests that faulting is initiated first and that folding occurs adjacent to the fault as one block is dragged along the other, that is normal drag. However, folding might precede faulting. Drag folds representing bending of rock before it breaks. The use of drag folds intuitively inferring that the direction of folding is toward the direction of fault movement can be misleading because convexity opposite to the sense of displacement termed reverse drag is common. For example, rollover flexures on listric normal folds are hanging wall folds concave towards the slip direction. Reverse drag is hardly distinguished from normal drag when they appear separately. Besides, the orientation of drag folds is often not controlled by the movement direction but rather the intersection between bedding and the fault plane, and the drag may vary from reverse to normal from the center to the termination of faults. Therefore, drag should be used with extreme care to ascertain the sense of slip along faults. Trains of drag folds are common in incompetent layers between two competent layers in the proximity of thrust faults. Then NHLN folds. अच्छा, इसको भी हम पढ़े थे क्या, पहले था इस टर्मिनोलॉजी से एक है ना. In some non-cylindrically folded surface, doubly plunging and relatively short, nearly upright folds in parallel series have alternating antiform and synform axis oblique to the fold string. Such folds are stepped and consistently overlapping. They define an NHLN array. Note, however, that this term describes the geometry of the folded surface and is independent of the relationship of the structure to the horizontal and vertical. Taking these tip axial planes as roughly orthogonal to the shortening direction. Their distribution permits to decipher the potential fault they are related to. Such faults are common above strike slip faults that have not broken the cover but offset to the basement blocks. The N echelon fault pattern reveals the relative sense of movement along the basement fault. Drape faults or forced faults. Drape faults are generally open curvatures in a sedimentary layer that conforms passively to the configuration of underlying structures and geological bodies. An important shape controlling factor is whether the cover remains welded welded to or is detached from the basement. A fault formed by differential compaction is an example. ठीक है. Now force faults are generally fault related long and linear flexures that relative movements of basement blocks generate in cover rocks. Their overall shape and trend are dominated by the shape and trend of the underlying forcing fault blocks. They are typically monoclines with long gently dipping back limbs and short steeply dipping forelimbs, the latter overlying the fault surface. They are equally common in compression and extension regimes. The type and amount of fault movement control the fault profile geometry. नाउ थ्रस्ट रिलेटेड फोल्ड्स. सो थ्रस्ट मूवमेंट जनरेट्स जियोमेट्री. तो देखो सारी चीज़ें हमारे साथ लिंक्ड है, जैसे कि थ्रस्ट हम पढ़ते हैं बट वहाँ पर भी चीज़ें समझ में नहीं आती, मतलब वो पढ़ के. अब यहाँ पर आप समझ तो पाओगे बट थोड़ा डिफिकल्ट है. आपको अच्छे से 2-3 बार पढ़ने के बाद समझ में आएगा, मेरे को लग रहा है, क्योंकि मेरे को ज़्यादा कुछ समझ में नहीं आ रहा. ठीक है, थोड़ा हार्ड है, टर्मिनोलॉजीज जो भी है जियोलॉजिकल है. नाउ फोल्ड्स इन दी एलेक्थोनस हैंगिंग वॉल. ये एलेक्थोनस टर्म भी हमने पढ़े थे. हैंगिंग वॉल एज इट मूव्स ओवर टोपोग्राफिक इरेगुलरिटीज ऑफ द डीप थ्रस्ट फॉल्ट्स किंक लाइक बॉक्स फोल्ड्स रिजल्ट्स. ओके, तो थ्रस्ट रिलेटेड फॉल्ट्स ये अच्छे से समझो. नाउ टू टाइप्स ऑफ रैम्प रिलेटेड फोल्ड्स आर कॉमन इन थ्रस्ट बेल्ट्स. फॉल्ट बेंड फोल्ड्स. अच्छा, इमेज में क्या दिखा है? पैसिव फोल्डिंग ऑफ द हैंगिंग वॉल ऑफ ए फ्लैट एंड रैम्प थ्रस्ट सिस्टम. अच्छा, जो भी है. Now fault bend folds form and grow above a footwell ramp where a displacement plane steps from a lower flat to a higher one. As slip occurs, strata of the hanging wall slide over the fault bend. Passive syncline-anticline pairs at the base and top of the ramps accommodate in the hanging wall the shape of the footwell ramp. Specific geometries are maintained throughout the development of the folds. The anticline-syncline pair directly reflects the geometry of the fault bends. The ramp anticline terminates downward into the upper flat. The forelimb is shorter and steeper than the back limb. The back limb is parallel to the footwall ramp. Now, in a fault propagation fold, the ramp does not continue to an upper flat. Strata cut by the base of the ramp are shortened by thrusting. Fault slip decreases to 0 in the up section direction and the fault dies out into the axial surface of a syncline. Strata above and in advance of the upper tip line of the propagating thrust are shortened entirely by folding typically. Such folds are asymmetric in the direction of thrust movement. They tighten with increasing displacement and both limbs lengthen while the fault tip propagates upwards. Antiformal structures commonly grow over a ramp or a duplex zone to build antiformal stacks. Growth folds develop in sedimentary strata deposited at the same time as folding. The regional scale association of folds and thrust defines a fold and thrust belt. Owing to the systematic and predictable geometric relation between a fold and the fault plane that generated it, the fold geometry can be used to infer the fault position and shape at depth. Normal fault related folds. So as in thrust system, shape and topographic irregularities of extensional faults generate folds. Now, rollover anticlines are gentle convex bending of upper block beds towards the main listrix fault. They form half antiforms geometrically necessary to accommodate the concavity of the causal fault. As the hanging wall slips along the dip, gently dipping to flat lying parts of the fault, an empty space opens between the displaced hanging wall and the shallower, steeper parts of the fault. Beds initially horizontal in the hanging wall must tilt and become gently convex upwards to fill up this space. Growth faults associated with normal faults are common. The geometry and size of these faults change as slip accumulates on the normal fault. These changes affect the distribution of concomitant sediments, generally producing wedge-shaped layers thinning towards the fault. The folded beds become gently concave upwards. Unconformities develop towards the fold crest and the fault. These same unconformities pass into the correlative conformities in the adjacent basin. Now, tear faults in areas like the Jura, strike slip faults seem to tear the fold across. Such faults are attributed to differential advance of adjoining segments of the folds, with folds in one block being more closed and tighter than in the other. Tear faults as such are transfer faults that originated during folding. Now, fracture patterns in folds, geometry and density of fractures accommodate the strain induced in the strata during folding. Fracture sets usually vary from hinge to limb. In hinge regions, fractures are mostly parallel to the fold axis and orthogonal or to bedding. Curvature related extensional stresses within the outer arc of the fold generate joints, and normal faults compressional stresses generate stylolytic joints and thrusts within the inner arc. In limbs, fractures are mostly parallel to the fold axis but oblique to bedding. They are related to interbed slip. Primary folds. Lavas commonly develop surface folds during flow. These folds are due to the different properties of the chilled outer crust of the lava relative to the hot, faster flowing inner part. In magmatic rocks, folds often deform the primary banding during the late stage flow of the magma. Non-lithified sediments are suspensions that can deform in a ductile manner. Gravity-driven sliding, slumping of unconsolidated layers often produces complex fold shapes called slumps. Slumped layers typically lay between undeformed strata, determining a shear direction from fold orientation. So layers in sheared rocks commonly form non-cylindrical drag folds whose axial planes are near the shear plane. Sheath folds, ये sheath folds के बारे में हमने पढ़ा था. Being one end member of this geometry, these hinges are carved because their orientation depends on several parameters such as the original orientation of the layer relative to the shear plane and local heterogeneity of flow. Did you struggle with remembering about these sheath folds? And you should definitely check out it. So these terminologies can be asked in geography sometimes, so that is important. Other much detail is not required here. Therefore, fold hinges are rarely orthogonal to the slip direction. Because of such important local changes, isolated small scale folds alone frequently give misleading transport directions. A safe assumption is that the asymmetry of any fold pertaining to the same set is consistent with the sense of shear that produced them. This consistency is the basis of the geometric method that provides a guide to the slip direction. The Hansen method considers a group of minor folds and proceeds as follows. All hinge orientations are plotted on a stereo net with their sense of asymmetry. All hinges should lie approximately on the same axial plane, that is great circle, near the shear plane. The separation arc of the great circle across which the sense of asymmetry becomes opposite contains the slip direction approximately along the bisector of the angle defining this arc. The asymmetry of folds defines the bulk sense of shear. Now conclusion, हम लास्ट पार्ट में आ गए कि a fold is a band in a layered rock caused by compressive stress, buckling or passive draping of layers over a deeper structure including normal folds or around a resistant object. Folds display a wide range of shapes and result from a wide range of processes that all largely reflect the rock behavior. Therefore, geometrical characteristics commonly change within the same fold from layer to layer. Folds represent a large-scale flow of material and record periods of rock deformation. Therefore, generations need to be distinguished and dated. For these reasons, structural geologists have to document the layer configurations as clues to conditions of deformation and folding history. This information has economic and geologic hazard applications. Folds form associated with faults and thus can signal earthquake hazards. Folds host ore deposits in hinge areas due to the flow of fluids to those localities. For example, antiforms are hydrocarbon reservoirs. Okay, तो ये देखो, ये important काम है भाई कि एंटीफॉर्म्स आर हाइड्रोकार्बन रिजर्वर्स. ठीक है, ये हमने पढ़ा भी था पहले कभी, मतलब क्वेश्चन में भी था, कहीं मैंने दिखा था, तो वहाँ से सर्च करके मेरे को निकालना पड़ा था इसका आंसर. ठीक है, देखो ये अच्छी बात है। फोल्ड्स होस्ट और डिपॉजिट्स इन हिंज एरियाज, तो हिंज जो हमने पढ़ा था ना, हिंज एरियाज, ड्यू टू द फ्लो ऑफ फ्लूइड्स टू दोज लोकेलिटीज। तो एंटी फॉर्म्स आर हाइड्रोकार्बन रिजर्वर्स, तो ये याद रखना, ये सारी चीज़ें देख लो। तो यही बेसिक पढ़ने का मतलब यही था कि यार कुछ चीज़ें अगर मिल जाए जो हमारी काम की हो, एक बार तो पढ़ लेते हैं, क्योंकि ये सारी चीज़ें आसानी से आपको कहीं नहीं लिखा हुआ मिलेगा। जो भी कॉमन हमारा टेक्स्ट बुक होता है ज्योग्राफी का, तो थोड़ा आपको एडवांस लेवल पर जाना पड़ेगा, कुछ चीज़ें आपको एक्स्ट्रा निकालनी है, तो ठीक है, तो ये बात है। और एज यूजीसी नेट मेंटर तो पढ़ना ही पड़ेगा, थोड़ा बहुत तो एडवांस चीज़ें पता होना चाहिए ना आपको। तो पढ़िएगा, ये सारी चीज़ें पढ़िएगा, यहाँ से नोट डाउन करिएगा। और आई विश ऑल द बेस्ट फॉर योर अपकमिंग एग्जामिनेशंस। थैंक यू फ्रेंड्स।